Hey guys, so welcome back. So I'm gonna walk you through the Aldol reaction. Good news, we are done with organic. I've finished all the slides. So on this next is to record these videos. So I'm excited, and I'm not too sure what I'm doing next. I'm gonna do bio in some combination of another class. The thing about the bio book, it's like the longest. It's gonna take me forever. So I might do like either bio and biochem or bio and gen chem. Definitely not physics because I don't think I'm at that level yet. But I also kind of want to do psych social. So we'll see. Okay, why about we just focus on all else, Joe? How about that? Okay, so pretty much the first thing you should recognize by the name, and this is annoying, but aldehyde and alcohol, right? Aldol. So an aldol is a group that has both an aldehyde and an alcohol. But the annoying part is it can actually also be ketones too. So it like makes the name make a lot less sense. But this is also an aldol, sadly. I know, it's like, how do I explain that? I just can't. So yeah, these are important when it comes to biochem. Specifically, there is a enzyme in glycolysis called aldolase. So understanding like aldols and what they are is definitely very important. So as we walk through the mechanism, first you need to know is, hopefully this term, everyone knows it by now, but one carbon away is the alpha carbon, okay? So this carbon has two alpha carbons, and the significance of alpha carbons is the hydrogens coming off of those are really reactive. Okay, they have a pKa of around 19.6. Okay, so they're reactive. So what's gonna happen is a base is gonna come here and pretty much take electrons from the hydrogen. So we're going to pick up the hydrogen to make H2O, and then we're going to put those electrons to make a double bond. Hold on, let me highlight it. So here we take these, right? And then remember that your hydrogen is going to be slightly positive, and then your carbon in this case is going to be slightly negative. It won't always be slightly negative. So this carbon can then make a double bond, and then we can get to this structure. Now, I want to draw the resonance structure, and I'll do that in a different color. It would look like this. You could have a negative charge there, hydrogen there, positive here. Now, don't draw this structure ever, but I kind of heard there's some common questions about, oh, how does this just magically dump electrons? Well, if we look at the resonance structure, we see. Oh, hey, look, I flipped the molecule. That is so my bad. These are the same molecule, I just flipped it. But if we look at the resonance structures, we see that there's a negative charge. Actually, let me just fix that. Let's go to here. Wait, never mind, I'm stupid. It was a ketone the whole time. Oh, how embarrassing. Okay, so this negative charge goes there. So because this negative charge is there, then we make this to go here. And then that takes us back to that structure. Okay, so these two exist, but the one in green is more favored due to stability, and this molecule here has too many charges. Okay, so what you need to know is, again, aldol, right? So when you get this, also you should know that this is called an enol, but when you get your enol and then your aldehyde, we know that I always go back to resin structures. So if we draw this structure, we see that there's a positive charge there. So that positive charge is going to tell us that that we're going to, again, negative to positive always, right? So there's technically a slightly negative there. So whenever you have a negative charge and then we see here that this is a positive charge, then we can go ahead and attach, right? So negative to positive here. And then we get this structure. Now we know that we don't like charges, right? We don't like charges, so that's when we're going to use an H plus ion in solution. And then there we go. You have your aldol or your ketol. That's what I call the second one because chemists decided to name them the same thing. Those guys are weird. So you can go back and forth. So yeah, so you can like sort of split it. Yeah. So this is with a ketone right now. So you can like split it in half or you can reform it. It's reversible depending on what you use. And again, this is what I would call a ketol, not an aldol. So that's that. And then one last thing. Also, I don't know if this is E1. I don't know why I wrote that. You can do this reaction here. Oh, no, it definitely is E1. It is an E1 reaction. So if for those who don't remember, we're going to go through it really quickly. So you have a leaving group. Your leaving group leaves. Okay, and then now you have HSO4 minus. Okay, and that is really basic, right? So we're gonna take these here, dump those there, and then we get that. Okay, and this is, I think, what we're gonna call full Aldol condensation. So hopefully that was very helpful. Definitely try to understand the premise of the reaction. And again, when we go through these mechanisms, it's not like they're going to ask you draw an Aldol condensation, right? But you never know what you're going to see on this test. So I would definitely know generally what it is, and it's definitely good to know the properties as well. So I'll see you guys in carboxylic acid. Yeah, bye. See you.